So imagine you hire like the world's most famous, highly recommended architect to build a perfectly standard structure in your backyard.
Okay.
You hand them the blueprints, they look at the plans, they look at you, and they just say, no.
Yeah, they just completely refuse the job. And the kicker is, I mean, they have all the necessary skills, all the materials, the tools to build that exact structure without breaking a single drop of sweat. They just won't do it.
Right, you'd be left standing there thinking you were in the twilight zone. Today, you and I are taking a deep dive into an absolutely fascinating experiment that is basically the digital equivalent of that exact scenario.
It really is.
So we're looking at a detailed developer diary and a testing log from a team of engineers. And our mission today is to look at this comparative test where 4 major AI models, so that's Claude, ChatGPT, Gemini, and Grok, were all tasked with writing BlenderPython code to generate a specific 3D model.
And the narrative that unfolds from these testing logs is, honestly, it's incredibly revealing. Because, this isn't just a standard benchmark test where we rank AIs on a leaderboard to see who types fastest.
Right, like a simple speed test.
Exactly. It's fundamentally a story about AI behavior, the hidden friction in how these models process language, and really how human engineers have to fundamentally alter their approach to get any results at all.
Okay, let's unpack this, because it's really a story about why one of the most famous AIs on the planet stubbornly refused to do the work, and how human engineers had to creatively coax it across the finish line.
Yeah.
And ultimately, how changing the underlying rules of the game took the entire project from a state of, fragile failure to absolute perfection.
To understand the refusal, we first have to understand the assignment. So the engineers created what they called the version 5 requirements document, which was a single batch specification.
Just one big prompt.
Right. And the goal was seemingly simple. Write a script to build a 3D model consisting of 2 hexagonal prisms and 1 16-sided support rod.
But the catch was the method, right? Because they had to build it using raw vertex math and Python dictionary data.
Yes, which is brutal.
Yeah, for anyone listening who hasn't dabbled in 3D modeling, that basically means defining the geometry point by point in 3-dimensional space. And the spec also specifically required that all outside faces of that 16-sided support rod had to be pointing outward.
Right, so they're calculating raw X, Y, and Z coordinates from scratch. So the engineers feed this version 5 batch spec to the 4 models. And the initial results are pretty stark. I mean, Claude, Gemini, and Grok all read the single prompt, process the math, and flawlessly build the fully compliant model on their very first try.
Just one shot, boom, done.
Exactly.
But then we get to ChatGPT, and this is where our architect walks off the job. ChatGPT outright refused to build it.
Just flat out no.
Yeah, and what's wild to me is that the engineers even tried to negotiate with it. They specifically rewrote the requirements to remove the exact sticking points that ChatGPT claimed were the reasons for its refusal. They handed it the sanitized version 5 spec, and it still balked.
Well, this perfectly highlights how complex the interaction layer of large language models has become. Because we tend to think of them as deterministic machines, right?
Yeah.
Like you put a prompt in, you get code out.
Right. Input equals output.
Exactly. But there are safety filters, alignment training, and behavioral guardrails layered all on top of the base mathematical model.
Which brings us to the excuses. Because if you hire a contractor who looks at perfectly normal blueprints and quits, you really want to know why. Why would a highly capable AI just say no?
What's fascinating here is that when pressed, ChatGPT provided 2 mutually inconsistent explanations for why it wouldn't do the work.
Okay.
So the first excuse was entirely semantic. It was what we might call the scary words excuse.
The scary words excuse, I love that.
Yeah, so ChatGPT claimed that certain phrasing in the prompt words like production, complete, verified, implement every requirement, and return as a downloadable file, those words triggered a hesitation.
Wow.
It couldn't honestly commit to delivering on those really heavy absolute terms.
I have to pause you there because that sounds so human it got stage fright.
Pretty much, yeah.
But let's look under the hood for a second. Why does an AI care if I call a script production ready? What is the actual mechanism causing it to hesitate there?
Well, it comes down to something called RLHF.
Mm-hmm.
That's reinforcement learning from human feedback.
Okay, right.
So during its safety and alignment training, the model is repeatedly penalized by human graders for making guarantees about high-stakes real-world environments. So if a model generates a script and says, hey, this is verified production code, and then a human runs it and it crashes the server.
Oh, that's a massive liability.
Huge liability. So its underlying alignment weights act kind of like a tripwire. When it sees terms like production, the model's internal probability shifts toward avoidance and hedging, basically just to avoid being penalized by its training parameters.
So it's essentially been conditioned to flinch at corporate jargon.
Exactly.
It essentially said, I can write the code, but if you call it production code, that's just too much pressure. And this is the crazy part, it completely changed its story later.
It did. The second explanation it offered was entirely different. It claimed that it suffers from a sort of preemptive overwhelm.
Overwhelm.
Yeah, it stated that it overestimates the size and complexity of code before it even starts writing. And that internal overestimate is what leads it to, just throw its hands up and abandon the script.
Crucially, though, neither of these excuses had anything to do with the actual geometry.
Right at all.
Like, it wasn't saying, oh, a 16-sided support rod is mathematically impossible. The limitation wasn't in the math or the AI's actual processing capabilities. It was entirely in its own behavioral framing.
Which forces the engineers into a very interesting position, right? If a single comprehensive batch prompt fails because the AI gets tripped up by its own safety weights or, scope estimation, how do you extract the code?
Yeah.
It is fully capable of writing.
You have to coax it. And this leads us to the workaround they use in the developer logs, which was, honestly, an exercise in extreme patience. Because that single batch prompt failed, they broke the specification down into 4 separate incremental steps. They spoon-fed it the requirements one piece at a time, and they verified each step live in Blender.
And it is worth noting here that throughout this incremental process, the orientation of the faces and the normals, which is a really specific requirement, that was never an issue for ChatGPT.
Oh, really?
Yeah, the rule for how the faces should align was included from the start, and it handled the raw geometry of that part perfectly. The issue was purely about the delivery method.
Okay, so by feeding it the project piece by piece, they finally get a working script. But hold on, if ChatGPT is so advanced, why did this step-by-step method result in a bloated 250-line spaghetti code mess? I mean, shouldn't it be optimizing as it goes?
Well, you would think so, but breaking a task into tiny chunks creates what we call context fragmentation.
Okay.
When you ask for a script all at once, the model can plan a unified structure. It can create a single function to handle recurring tasks. But when you ask it for part 1 and then later ask for part 2, it often just slaps the new code onto the end of the old code.
Oh, I see.
Yeah, it repeats variables, it duplicates logic, and it loses the holistic view of the architecture. It's prioritizing immediate compliance with your newest prompt over the overall efficiency of the file.
That makes total sense. You can't fairly compare a 250-line stitched-together script against the sleek one-shot code produced by Claude, Gemini, and Grok.
No, not at all.
So to make a fair comparison, the engineers had to undertake a really rigorous cleanup process to shrink those 250 lines down. And they did this using a series of 3 highly specific prompts.
Right, and this is where we see the dual nature of how the model interprets instructions. So the first prompt asked for 7 specific structural changes. It asked ChatGPT to consolidate the separate build blocks into one reusable function, add mesh validation, add a stack height assertion, explicitly set flat shading, add a cleanup step, keep the 3 objects separate, and finally return everything as one file.
And that worked beautifully, right? It took the 250 lines and squashed them down into a much more efficient 47-line model.
It did. But then a separate AI analysis tool flagged some maintainability concerns with those 47 lines.
Of course it did.
Right. So the engineers went back with a second prompt. This one was all about retention. They told ChatGPT not to rely on its memory of earlier scripts. They demanded it restore a missing safety assertion, and they required it to keep the descriptive variable names and add short comments above each section.
Which bumped the code back up to a 90-line model. It restored the missing pieces. But the third and final prompt is where it gets really interesting for me.
Oh yeah, this is the best part.
The engineers asked for 2 very small changes. Basically, move 1 assertion so it ran before the geometry was built, and add 2 print statements to confirm it. But, and this is key, they explicitly told ChatGPT what not to touch. Like, no renaming, no restructuring, no changes to the geometry whatsoever.
And it followed those negative constraints flawlessly. It resulted in a final 92-line model that met every single requirement of the version 5 spec and was completely comparable to the final scripts from the other 3 AIs.
It's a massive irony. I mean, wait, so the AI that completely panicked and refused to build a model because the original prompt asked for complete production code was suddenly perfectly capable of following incredibly strict, rigid, negative constraints To the absolute letter.
Exactly. The broader lesson for anyone using these tools is that asking for a full production rewrite just invites chaos. The AI might think, oh, production code, I better tear this whole thing down and start from scratch to ensure it meets that lofty standard.
Right.
But when you name the exact changes and forbid anything else, you constrain its predictive pathways. It stays precisely within those bounds.
So if you want predictable changes, you have to ask for specific named increments. Okay, so we finally squeezed this perfect code out of ChatGPT. You'd think we're done.
You'd think so.
But the engineers decided to run that 47-line code through another AI to review it. And this brings us to one of the most dangerous traps in modern coding, which is the fragility of AI trust. Because that analysis tool came back with 3 specific critiques of the 47-line script. And spoiler alert, it wasn't exactly a reliable narrator.
No, it wasn't. Let's break down those 3 critiques. First, the AI reviewing tool claimed the 47-line code stripped out a vital tangency safety assertion. And would check that against the source file. That claim was actually true. The assertion was genuinely missing.
Okay, so 1 for 1. But then it went completely off the rails.
Totally off the rails.
Yeah.
The second claim was that the code removed descriptive variables in favor of magic numbers.
Magic number.
Yeah, which are basically unexplained, raw numbers just sitting in the code without context. But this claim was entirely false. A direct manual check against the file showed that the script kept every named constant throughout. There were no bare, unexplained numbers anywhere.
So it just hallucinated a best practices violation. But why? Like, why would an AI reviewing code invent a flaw that isn't even there?
Because an AI code reviewer isn't actually compiling and testing the code. It is a text prediction engine. When prompted to critique this code, it matches patterns against its training data of millions of code reviews on GitHub and Stack Overflow.
I see.
And magic numbers is an incredibly common critique in human code reviews. So the AI statistically predicts that mentioning magic numbers sounds like a highly plausible professional critique, regardless of what the actual text file contains.
It's like using a spell checker that confidently introduces grammar errors into your essay, but it speaks with such authority you just assume it's right. You can't just take an AI summary of a diff at face value.
Exactly, and it didn't stop there. The third claim was that all diagnostic feedback was silenced.
Which was massively overstated. The feedback was reduced, yeah, but it wasn't silenced. There were still 3 print statements remaining in the script.
Right. You absolutely still have to read the code, check the assertions yourself, and run the file. AI-generated code demands the exact same verification discipline as human-written code.
Absolutely.
And this actually ties into another technical illusion highlighted in the developer logs. The engineers noted an instruction in their prompt telling the AI not to rely on its memory of past chats, which brings up a really common misunderstanding about how these systems work at a fundamental level.
The illusion of memory.
Yes.
If you use AI at work and assume it knows you or remembers your company's style guide from yesterday, you are in for a rude awakening.
From the user's perspective, it often feels like the AI remembers you, like you open a new chat window and it casually references a project you talked about last week. But a base large language model architecture fundamentally has no memory. Its neural weights are frozen. It retains absolutely nothing between separate sessions.
So if the weights are frozen, how is it bringing up last week's project? It feels like it remembers.
Right, because modern AI products layer memory retrieval features on top of the base model, often using a system called Retrieval Augmented Generation, or RJ.
Okay, RJ.
Yeah. So they have a separate traditional database that stores facts from past conversations. When you start a new chat, the system does a quick search of that database and automatically feeds those relevant facts into the hidden context window, the system prompt, before you even type your first word.
It's not memory. It's like the AI is being handed a cheat sheet about you right before it walks into the room.
That's a perfect analogy, yeah.
So you are completely at the mercy of whatever facts its hidden search tool decide to pull up today. So if an AI claims it has no memory, that might be technically true of its base architecture, but highly misleading about the actual product you were interacting with, if that cheat sheet feature is turned on.
It's a critical distinction for data privacy, and really just for understanding how your prompts are actually being processed.
Okay, so we've coaxed ChatGPT to a comparable script. We've navigated the flawed critiques and the memory illusions. The version 5 batch spec is technically complete.
Finally.
But the story doesn't end there. Because the engineers had a massive realization. The entire premise of version 5, relying on raw vertex math to build shapes, was inherently flawed from the start.
It was a massive failure surface. Think about what we were asking the AIs to do in version 5. We were asking models like ChatGPT, Claude, Gemini, and Grok to generate low-level mesh geometry from scratch.
Right, without eyes.
Exactly. They have no visual feedback. They cannot execute the code, render it, or visually inspect the Blender output to see if the shape actually looks right.
It's like playing a game of chess by mail without a board in front of you. You have to hold the entire complex geometry of the game state perfectly in your short-term memory. And when you are dealing with hundreds of coordinates, that's where the AI's math just breaks down.
Because of this lack of spatial grounding, all 4 models initially struggled mightily with the underlying math. The logs note they ran into issues with vertex winding order, inverted normals, and broken topology.
Wait, vertex winding order. For those of us who aren't 3D animators, how does a winding order break a model?
Okay, imagine drawing a square by connecting 4 dots. A 3D engine needs to know which side is the outside of that square. It determines this by the order you connect the dots clockwise or counterclockwise.
Okay.
That's the winding order. If AI mixes up the order, the 3D engine gets confused. The face might twist in on itself, or you get what are called inverted normals, where the software thinks the inside of the object is actually the outside. The texture basically renders inside out.
Oh, wow. And broken topology just means the math doesn't create a closed, watertight shape, right?
Wrong.
So you end up with 200 lines of fragile math that frequently fails the moment you try to actually import it into Blender. It makes complete sense. I mean, this is like asking a master chef to grow their own wheat, mill their own flour, and churn their own butter just to make a sandwich.
Yes.
Versus handing them high-quality, pre-made ingredients and saying, now cook. Obviously, the second method is going to yield better, more consistent results.
And that realization triggered the pivot to what they called the version 6 framework. They updated the requirements and gave it to all 4 AI models. And the shift was profound. Because instead of raw math and polygons, version 6 was all about primitives.
Primitives over polygons. So what does that actually mean in the code? Like, how does a primitive bypass that whole winding order problem?
It means the AIs were strictly constrained to use standard Blender primitive operators.
Yeah.
Specifically, a built-in Python function called bpy.ops.mesh.primitiveCylinderAdd.
Okay, a built-in function.
Right. So instead of calculating where every single vertex should sit in space and hoping the winding order is right, the AI simply acts as a parameter generator.
Oh, I see.
Yeah, it defines the radius, the depth, the location, and the rotation, and then it hands the execution off to Blender's native tools. Blender already knows how to perfectly draw a cylinder. The AI just tells it where to put it and how big to make it.
So let Blender do the heavy lifting for the geometry and let the AI do the logic and placement. And the results of this version 6 pivot were staggering, weren't they?
An absolute success across the board. I mean, every single model, Claude, ChatGPT, Gemini, and Grok, produced a perfect 100% compliant assembly on the very first run.
No coaxing required.
None. Every model output exactly 100 triangles with outward-facing normals and flawless geometry. The friction we saw in version 5 completely vanished.
What's really cool about that is that even though they all succeeded perfectly using these high-level tools, you can still see the distinct personalities or like programming styles of the different models when you look at the line counts of their version 6 code.
Yeah, the verbosity varied significantly. So ChatGPT, which had struggled so much with the open-ended nature of version 5, generated a sleek, minimalist script of just 28 lines. It did exactly what was asked and nothing more.
Minimalist and efficient. What about the others?
Grok delivered a 93-line script, and it used that extra space to include defensive workspace mode checks to ensure idempotency.
Idempotency. Okay, I know I've heard that term in computer science, but give me the ELI 5 for this context.
So idempotency just means you can run the same script 100 times in a row, and the result is exactly the same as if you ran it once.
Ah, got it.
In Blender, if a script isn't idempotent, running it twice might spawn a second set of overlapping cylinders inside the first set, completely ruining your file. So Grok proactively added safety checks to delete old geometry before building the new geometry, ensuring the workspace stayed clean.
That is a brilliant safeguard. And what about Gemini and Claude?
Gemini came in at 104 lines, featuring comprehensive console diagnostics. And Claude delivered 107 lines, complete with extensive inline documentation and parametric safety checks.
Amazing.
Yeah, they all arrive at the exact same perfect physical geometry, but they wrap it in completely different levels of safety, documentation, and diagnostics.
It proves that when AI code generation is guided by the right framework, using native tools rather than brute forcing low-level math, complex workflows become fully reliable, reproducible, and ready for production.
The primary lesson from these developer logs is that steady verification always beats one-shot generation. We have to treat AI output with the exact same scrutiny we apply to human output. Read the diffs, check the assertions, run the code.
Yeah, and if you want predictable changes, ask for specific named increments, and don't trust the AI code reviewer blindly. But beyond the coding best practices, this deep dive leaves us with a much bigger concept to chew on. So, what does this all mean? If all four of these powerful AI models shifted from fragile, frustrating failure to absolute 100% perfection simply by being constrained to use existing high-level primitives, it raises a profound question about the future of software engineering.
It really changes how we view the role of the human programmer in an AI-driven world.
Exactly. I mean, think about it. If AIs are at their absolute best when they act as parameter generators for existing high-level software primitives, does the future of human coding look entirely different?
It might.
Maybe in 5 years, human engineers won't be writing syntax or logic loops at all. Maybe our entire job will shift to designing the ultimate foolproof primitives like the unbreakable building blocks, and then we just let the AI play in the sandbox we build.
We stop building the applications. We start building the tools the AI uses to build the applications.
It's a wild paradigm shift to think about. We aren't being replaced. Our level of abstraction is just moving one layer higher. Something for you to ponder the next time you sit down to write a prompt or critique an AI's output. Until next time, keep digging deeper.